Hello again, this is Christopher Parham, otherwise known as Ice Cube 57 on the Atmosphere Forum, and we are on podcast number 6. I've been trying to keep these a little bit shorter so you can get some knowledge in on the way to work or just whenever rather quickly. So I'm trying to keep them under the 20 to 30 minutes. But let's hop right on into things. Today we'll be talking about um, running components at or exceeding their limits and trying to create some type of longevity, stability, and just trying to just reduce problems. Overall, you want to create a solid e-bike. So there's a few topics I want to hit, like especially about the battery, controller, motor, and bike frames. So let's go into the battery. Me personally, over the years, I've learned to put, a lot of my money into my battery. And the reason why I do that is you have a good battery, a good, solid, reliable battery that you either checked or, you spent the money on for a large pack, then you're going to get a good lifespan and a lot of cycles out of it. I prefer larger packs and higher amp hour. If it's 20 amp hours or less, I'm not really interested in it for personal use. And the reason why I do this is because larger packs, you can get more cycles out of them. You're not hitting them so hard. Uh, as far as the amps and C rating, you're not hitting them that hard, and then you can go 2 to 3 rides in between charges. So you technically could get 2 to 3 times the lifespan out of a pack versus somebody that has an 8 or 10 amp hour battery and they're going through pretty much almost 100% every cycle. Like me, but a person like me, I'm getting 2 to 3 rides and still have 20-30% left in my battery. So that keeps a lot of wear and tear off the battery. And then also staying well below the C rating of the pack. We have different types of chemistries and brands and everything out there. Just know that Hobby King LiPo is pretty much rated at 1/4 of its actual rating. So if it's a 10C battery, you're going to realistically get 2.5C out of it continuously. And and just by running the pack at a lower C rating or a lower amperage, you can get more cycles out of it that way. Because typically some of these packs, the harder you hit them, the more they heat up, the internal resistance goes up. You start abusing them after a certain point. But if you keep your pack size large, therefore keeping the total amps that each cell see very low, you can get a little bit more cycles and longevity out of the pack. Then there are certain times where you pay for certain brands, like if you're people getting a lot of cycles out of Ping batteries, and it just I had a Ping battery once, and it was for it was a decent battery. It was just, again, with Ping will pretty much configure anything that you want. He'll let you know if it's too much, but if you really don't care and you still need the power, he'll slap a 40 amp BMS on a 15 amp hour battery. You're pushing the shit out of it. It'll work. You won't get as many cycles, but he's a reputable vendor with a reputable pack. And like again, it goes to how hard you're hitting these batteries determines your life cycle, your cycle count, and how well it stands the test of time. So there's Ping battery. For a while we had VP Power, and that's kind of one of the shady eBay vendors. You got Cali Bike. I believe Cali Bike is a decent company. Just stay well within their specs. I wouldn't push their batteries too hard, but they do have the BMS on it to where you can push them pretty aggressively. But there's just certain types of packs you just want to stay in the 1 to 2C range, and not really, even though the cells may be capable of a little bit more, or a lot more. The BMS may be capable of a lot more. You're just asking for a failure down the road. So that's just something else to keep in mind. I'm not going to go into, too many vendors or whatever, but just stay well below the C rating of the pack. And don't pull too many amps from it. Go don't go all the way into the goodie basket and get all of that capacity out. Just because you have a 10 amp hour battery doesn't mean you have to use 10 amp hours. If you really needed to use all of it, you should have got a 12 or a 15 amp hour battery. And again, that goes to shifting more of your money towards buying a good battery, um, and buying more capacity than you actually need. It will help you a whole lot in the long run. Now, going over to the controller. Um, the controller is one of those tricky situations to where it really depends on what motor you have, what your attendant speed is, how many heels you have, and if you do have any obstacles and stuff, how long are you gonna be plowing through that? You can have a high turn motor or slower motor, and you can put impressively small controllers on them and get away with it. And like I said, if you live in a flat city, that'll be totally fine. So you can get away with a 6 FET on a high turn motor. Um, and you can keep the temperatures in check with the motor and the controller and get decent performance out of it. But the higher you go in speed, typically the more FETs you need in a motor controller. So, looking at your terrain, if you have, you know, relatively flat terrain with like maybe one or two hills, um, you can get away with a 6 FET, or possibly a 6 FET is pretty much as low as you can go, for the most part. A 6 FET or a 9 FET is for those entry level people, like I said, that live in flat areas, that have high turn motors, and don't need a lot of speed or performance. Once you start getting into the 12 and 15 FET controllers, these are the people that need a little bit more performance. Now, let me just roll back to the 6 FET. The 6 FETs are normally rated anywhere for 15 to 25 amp standard. You can push them a little bit harder, but you're asking for trouble. This is what the controller was designed for, to stay within that amperage range, 15 to 25 amps. That's what it can run pretty much all day without issue, without any overheating issues or whatever. I have a 6 FET controller. That's a 3077 MOSFET controller that I push up to 40 amps. The FET can take a little bit more, it has less resistance, so it's not generating as much heat, so you can push it a little bit more. But you realistically, like if you're pushing 40 amps, that's when you start crossing over into the 12 FET controller, which is rated for like 40 to 50 amps. Um, and this is for your mid-grade people that want 3,000 watts. I would say 2,000 to 4,000 watts on a 12 FET controller. And like I said, Lynn makes pretty impressive controllers. And you can ask them to reinforce controllers, beef up the traces, and put better wire, or better caps and stuff. And you can request all this stuff you're going to pay for, but you can request it and you can build a solid bulletproof 12 FET controller. But by no means you can overclock this thing to 100 amps. And then so like I said, it goes to are you really trying to cruise, cruise and maintain a certain level speed or performance, or are you asking for short peaks, but relatively most of your commute is relatively tame? So, you can get these 12 FETs, and I'm not even sure Land sells 15 FET controller. I think it's pretty much 12s. But I've had 12 FET controllers. I remember I ran one on the Magic Pi at 6,000 watts, and it lasted me a good while. But but that's also kind of a slower, torqueier wound motor, so it's not really seeing the abuse that the motor isn't putting a smack down on the controller that the controller can't handle it. But like I said, if you go to a higher speed motor like a 3-turn Muxus motor or a high power Cycles motor, those controllers they sell 12 FET controllers. You can buy 18 FET, but some people cheap out. You can buy, but the 12 FETs normally, like on HPC motors, they normally be screaming bloody murder even in the flats, because it's just those high wound motors demand a lot of torque off the line and all the way up to top speed, and the amps never taper down, so it's pretty much asking the controller for 100% duty 100% of the time. And like, that's an exaggeration, but if you're seeking out performance out of a 12 FET, then you're asking for it. Like I said, I believe the 12 FETs, they're good for still long, steady riding at moderate speeds. I would say 25 to 30 miles an hour. You're staying within that speed range, and you might burst up to maybe a higher speed, possibly 35 or 40 miles per hour briefly, but by no means you can dog this controller out for long periods and expect it to be happy. It's just with like any e-bike device, you can get away with so much, but then eventually that heat will catch up with it. That heat, I guess, is sort of like a phenomenon called heat soak, where if the motor can't shed the heat, or the controller can't shed the heat, it's like a snowball effect, and it's just a compounding thing until it gets to a critical point to where you're popping fats and everything. If you put your hand on the controller and it's hot, and you can't leave your hand on it for more than 2 to 3 seconds, that you pretty much got either you're riding it too hard, or you don't have the appropriate controller for your riding style or terrain. Um, Now, I personally, I'm moving to the 18 FETs now. Now, I personally have a Muxus 4-turn motor, Muxus 3000 watt 4-turn motor, and I'm pairing it with the 18 FET controller. And these 18 FET controllers are rated for 65 amp stock. But again, like I said, you can ask Lynn to beef up the traces and everything, and they could easily put out 100. But again, like I said, if it's made for 65 amp stock and you're pushing it to 100, you're pushing it well beyond what it was designed for. But if you need 100 amps peak, like off the line or to get out of a jam or whatever, that's fine and dandy if you're only going to be peaking for a short period of time. But like typically with my motor, sorry about that. Typically with my motor, I can peak 6,000 to 7,000 watts off the line, and when I reach top speed, it's only using 3,000 watts. So that's well within the continuous duty limits of the motor. The motor is rated for 3,000 watts continuous. And it just so happens that top speed, I'm running 66 volts. So that gives me a top speed of 45 miles an hour. And at 45 miles an hour, I'm hovering right around 3,000 watts. So, I can peak for a short period of time with the controller accelerating off the line. But when I get up to my cruising speed, I'm, well within the limits of the motor and well within the limits of the controller. So to put things into perspective, like I said, if I'm running a 4110 controller, so I can do up to 100. I can do up to 100 volts at 65 amps, so that's 6,500 watts. So if my motor at top speed is only taking in 3,000 watts, I'm pretty much running that at a 50% duty cycle. So I should be able to run pretty much all day with this setup, as long as I'm not doing repeated jackrabbit starts and everything. But if you just want something bulletproof, you have to go up to the higher FET controllers. I was talking about the 18, then there's I guess there's I'm not sure, is there a 24 FET controller? But I think the next biggest one above that is a 36 FET. But at that point, you have so much power on tap. There's not too many hub motors that can take, 100 amps. 100 amps continuous. These controllers, like a 36 bit controller, can put out 100 amps continuous, and some people push them as high as 200 amps, or even higher, and in some cases. So we don't have any. Um, we don't have any 10,000 watt capable hub motors that can go on standard bike frames. I think we're tapping out around 6,000 watts. 6,000 watt motors that can take that continuous, and then those cost an arm and a leg. And unless you're made of money, nobody's really um, nobody's really pumping that much money into it unless they're just doing something absurdly retarded and stupid and just for shits and giggles. So so when we look at, like I said, we look at the motor controller and we look at the motor, and we typically want a controller that can do double, um, what the motor can take, but the motor needs to hover around half of what the controller can put out. So I have a perfect mix with my controller. I'm doing 3,000 watts, but my rig can put out 6,000, 7,000 watts. So that's kind of a good match. But if you have, like I said, these high FET controllers that can put out 10,000 watts, and you put it into a 3,000, 4,000 watt motor, and you're expecting continuous duty, um, it's just kind of silly and absurd. Because even if you like had all the special safety features, like the temp sensor and phase current limiting after so many seconds or so many minutes and everything, you're still wasting a lot of power. And the motor can take it short term, but long term is is very detrimental. There's no way that you can um, keep up this sort of power, because like with wind resistance and everything, the power requirements exponentially grows. So if you're trying to build a 50-mile-per-hour rig, with a subpar motor, you're going to burn that motor out quite quickly. And even when you have stuff like the cycle analyst and the thermal throttling, it's progressively pulling the power back. So if you're using the thermal throttling, you hot dogging your motor, and you actually have your cycle analyst set up correctly, you need to pay attention to the cycle analyst and look at what temperature the motor is running and how much current or how much wattage is allowing the motor to sip when it's at a critical point. I had mine set up to start regulating at 100C and start tapping out or giving me no power at 140C. So around 120, 125 is limiting me to 3,000 watts, which is what the continuous rating for the motor is. So if you have a 10,000 watt bike or whatever, but your motor, if you're looking at your cycle analysis and your motor is only giving you 2 to 3,000 watts, then you just technically spec something way over. Your controller is spec way over what the motor can take. Even on a burst basis. Then you got to look at, if you have 10,000 watts going into the motor and you're launching off the line, look at your efficiency off the line, and even up to 15, 20 miles an hour, you're wasting a ton of that power. And like I said, pretty much efficiency is a number that's 0 to up to the top speed of the motor, and the best motors on the market can do about 80 to 90% efficiency, but off the line you're sub 50%, so you're dumping 10 kilowatts into the motor. And I'm just even being generous, 5,000 watts of that is going to heat. Yes, you're ramping up the speed and that number is dynamically changing, but you're wasting a lot of power trying to get up to top speed. And I think I touched on this in a previous video. Um, when you got that much waste, do you really need that much power off the line when a lot of it is going to waste heat? And again, so you have 10,000 watts going into the motor. It's 50% efficient off the line, and that's just like, and that's me doing a bullshit average. So 5,000 watts is going towards heat. You have a motor that's, rated for 3,000 watts continuous. So even the waste heat is exceeding what the motor can take continuous. So, you're just wasting a lot of power, dumping a lot of heat into the motor, heating up the windings unnecessarily. And so, over time, those windings are going to get darker. The enamel's going to get brittle on there. You're going to start having shorts to the stator and everything just because you're seeking performance. And it's nice in the short run, but in the long run, especially if you don't have any vent holes in the motor, you can't use any smells to alert you. You're not running temp sensors, so or your side covers aren't drilled or whatever. There's a lot of things that you could be missing out on. That's clues or indicators that you're possibly burning the motor up or whatever. Um, so it's like I said, it goes to, like I said, having the proper, windings for your terrain and the speed that you want, having the proper controller, make sure that is not too big or too small for the, terrain um, that you're riding in. Let's say if you're doing technical riding, you're lugging the motor in the low efficiency range, then you really do want a larger controller. Let's say in the flats, it's pretty much you can run stock controllers and get away with it. But if you're lugging it, doing technical riding in, mud, grass, and all of that, it's loading the motor down. It's never getting up to top speed. And so the phase amps are the greatest at lower speeds, so you're dumping a lot of power into the motor. And again, that efficiency number comes into play. And so you're not getting great efficiency. A lot of it's going towards heat and everything. But if you had a slow winding motor, um, a slow winding with more turns and everything is a lot more efficient at lower speeds. And it's really, I almost believe that, one person should have multiple bikes for different scenarios. I have a speed bike, I have a pedal exercise bike, and then I have one that's kind of in the middle of the road. So I have 3 bikes. So I shouldn't have any downtime for riding, but if I'm hanging in traffic and I need performance or whatever, I'll take my speed bike. But if I'm just doing 20 miles per hour, I have a bike that's geared and set up for 20 miles per hour and is more efficient, at that range versus, my speed bike, which I'm lugging the shit out of it. If, you know, 45 mile per hour bike, but you're lugging it around at 15, 20 miles an hour, it's not going to get good efficiency. But, if you have a slow wind motor, at the correct voltage and its top speed is 20 miles an hour, so that means that that motor is spinning at its closest to its top unloaded speed. So you can have a motor that does 25 miles per hour unloaded, but loaded it does 20 miles an hour. It's pretty close to, its most efficient range, and it's not wasting a lot of power. But, you have a high performance bike that's, you know, is doing like 50 miles an hour unloaded, 45 miles per hour loaded, but you're riding at 20 miles an hour. It's not getting that great of efficiency, and you're possibly wasting power. So there's too many scenarios to go over, uh, but just don't try to match your stuff up as best as possible, and don't I mean, I see people chasing performance bills, and it's like all of this power is just being, like wasted, unless you have a motor that can actually convert that, that electrical power into mechanical force and do it at a reasonable efficiency and not waste any of it. A good example is I have a friend that has a 5400 motor. This is like a 35 pound motor. He has the mass. He has the mass to dump power into it. I think he's running like a higher end Kelly controller. He put his way. He burnt up a Crow motor, which is one of the best motors that's out there for electric bikes. He burnt that up on his commute. He has like a 20 some odd mile commute into the city, and he burnt that up, pulling so many hills and everything. And now I suggested that he find a heavier motor, and I suggested the Crystalite. I think it's like either the 5403 or 5404, and that motor has a lot of heat sinking mass. It builds a lot of torque, and a lot of speed. And it's like right now the motor is almost too big for the controller that he has, because the controller was shut down if he blips the throttle too hard. So that means the inductance on the motor is kind of high, but he has that heat sinking mass to have continuous duty. He can have the speed, but before, what he was doing, and pulling all of these long kills and trying to maintain 45, 50 miles an hour on his commute so he doesn't get ran over, there was just a mismatch in parts, and he burnt out that motor. So, for longevity, I pointed him the direction to a heavier, beefier motor. And like I said, it's now at the point where, like I said, the motor is almost too big and beefy for the controller, but he's getting lower temps, more continuous duty, and he's not having any issues. So if you, I'm one of the people that definitely believe if you don't have time to do it right, make time to do it over. And I see a lot of people, they're doing it big, but they probably down the road, or some of them down the road, going to have some heartache because they just paired all this stuff, all the motor control, the motors, the controllers, the batteries. They're paired up all wrong because they and cut corners and cheaped out in certain places. But it's coming, yeah, they got something rolling, they're kind of enjoying it, but it's eventually going to come and nip them in the bud. So it was, definitely spending money it was definitely over the years. I used to be one of those cheap people that, oh, I want to build a bike for $500 or $1,000. And I remember, I ran lead acid, and I had so much lead acid on my bike. I had like 60, 70 pounds of lead acid on my bike trying to, get speed. And that's when I spent money on a cheap eBay battery and wasted money there. And everything. So, I would like for some of you people to start listening to some of these foreign veterans that have made the mistakes already for you. Save your money. Even if you're down another 2 weeks or a month, save your money, get the correct stuff, and, pair it up correctly, to where, you have something more solid. Because that bike will, just like if you have like a money pit car, you keep swapping out stuff on the bike and everything, upgrading stuff and this, that, and the other. You spend more money doing these upgrades trying to get it right versus saving the money, pairing everything up, getting everything right the first time, and you definitely spend a lot less money and have a lot more uptime. Because even me coming up, even swapping out a part, you get to the point where you swapped out the part, but you end up having to replace, some other things like connectors and nuts and bolts and this, that, and the other, trying to get this new part to work, this new upgraded part to work. And it's a lot of headache down the road. You spend more time tinkering and upgrading than you do riding. And I finally got to the point in the past 2 or 3 years where, I'm building it right the first time. There's really nothing else left for me to do on the bike but to ride it when the conditions are right. So, um, but yes, I did go through that phase where I was burning up motors and controllers. Ooh, I see like a $30, $40 controller on eBay, and then it wasn't fast enough, so I reprogrammed it, and it still wasn't fast enough. I wanted more amps, so I did the shunt mod and glopped some solder on the shunt, and now I got more amps. And then a week later, I done burnt out the FETs, and all of that. And like I said, I just learned to you learn to overbuild, but you overbuild to an extent to where, um, like I said, it's double what you need, but you realize that, you know, none of this stuff is continuous duty. It's like I said, it's just made to get you up to speed. You know, you're supposed to taper down. You know, if you build the bike correctly, it's supposed to taper down to a nice continuous duty to where the motor and the controller are happy and they're not fighting each other or getting pissed off with each other. Only way I can think of is like like I said, these people that have these huge controllers and the motors that can't take it. It's like the motor is like, it's too big, I'm like, you just got too much power going into the motor, and it's just going to get to a point where that motor is going to break, or, vice versa, or the motor is too big for the controller, and the motor wants more power than the controller can provide. So eventually the controller overheats and pops. So, you got to look at these numbers, look at the simulator and everything, and figure out what's best, save up the money, get the right stuff, and hopefully you can have a build that you just don't have to play around with. You don't have to tinker with, and try to make it better or squeeze more performance out of it, because you have plenty of performance that's on tap. It's there when you need it, but like I said, over the years, I just noticed that I just don't need that much power. Yes, it's nice to get me out of a jam, but that peak power is like hella dangerous. I mean, it's like it's getting to the point where you have so much power, so much acceleration that you're out accelerating cars and everything. But like I said, if you live in a city, you're just you're just wasting a lot of power. You jackrabbit stars just to get hit by another red light. And even if you have the right of way, like right away and the coast is clear, you don't need all that power if you by yourself, unless you just want the thrill, and then like I said, you pay for the consequences for that thrill. But like I said, I realized I can use half the power, get the same amount of speed. My acceleration, I mean, for me, I guess is more about the speed. The acceleration is a little bit deadly on my bike, but the speed, getting up to top speed, is another thing, and I can wait a few more seconds as long as I'm still outpacing cars and able to get up to top speed without requiring excessive amount of power. Then I'm good with it. And if I'm in a jam or I need to, I'm riding, I need to pass a car, yeah, I'll give it a boost. But there's just no need for me to run 6,000 watts continuous. It's just absurd, absurd amount of power, and I'm just putting unnecessary stress on my components, my motor, my controller, and everything. And even though I think I have the ideal setup, my controller still gets a little bit warm, my motor still gets a little bit warm, but it's not like it was back in the day where I'm having these 48 volt 1,000 watt hubs and I'm shoving 4,000 or 5,000 watts into it, expecting it to, be great and everything. And it's just even thinking back on the golden motor hub I had that was doing like 53 miles an hour at 96 volts. It was nice and all, but once you took that spin around the block and saturated that motor, the performance after that point were just degrading, to a point to where, the acceleration was spongy, the throttle response felt spongy and everything. So, if you want these, high powered builds and everything, you're gonna have to spend the money on the motor, the controller, make sure it has the heat sinking, capability to keep you in a, decent performance range and everything. And, I still preach about the Cycloanalyst V3 and temp sensors, in the past few years where I've used temp sensors, I've never burnt up a motor. Anytime before that, I took the cheap way out and got the regular Cycloanalyst and think I can monitor temps on my own, and I still end up smoking and burning motors. Once I put that temp sensor in there, never had that issue. So that's another thing to have the longevity of your parts. You know, give you more lifespan. It's just like I say, anything that's worth doing is worth overdoing, and don't let budget restraints. I mean, like I said, I know everybody wants to get out there and start riding, but it's just much easier to just wait and build it perfect, and then you can just enjoy countless hours without having to fiddle with anything. And you'll have a more solid, reliable bike. I haven't had anything ever since I finished my Muxus build. I haven't had anything, majorly go wrong other than like adjustment of brakes and my derailleurs, but nothing electrically has gone wrong on my bike. My packs are still in good balance. I'm still getting decent performance, excellent, balancing out of them. I'm not having to fight with that. I haven't, other than the initial setup of the controller, I haven't messed with the controller settings, or anything. And like I said, I've even taken power away from the bike, just to, make it a more pleasurable ride. But I'm not doing all this tweaking, having to, pull the motor off every other week and, this, that, and the other. It's just, I'm beyond that. So, take the veterans' advice and listen to them. And like I said, don't argue with them, and take our advice. We're telling you right. We're telling you how to do things right the first time to save money for you. And but I'm a strong believer. Like, yeah, you can lead a horse to water, but you can't make them drink. And that's a lot of you on the forum. We can tell you what to do and how to do it. Whatever you have budget restraints that you still want to go through with your project. I'm one of those type of people. I remember telling one of my friends, I hope something goes wrong with your bike. I really do. I hope something fails. I hope something blows up, and then you can go in there and figure out what's wrong and get a better understanding on why. I can tell you all the answers and everything, but if you don't know why, you're not going to have a healthy relationship, and it goes in one ear out the other. But when stuff goes wrong with your bills, and yeah, we have to deal with the moaning and groaning, my shit blew up or whatever. But I'm glad that happened to you, so you by yourself or we as community can come together and help each other figure out what's going on, and and that puts another nail in the coffin, the hope, in hopes of, we can get people to do things right the first time. But sometimes you have to have multiple people setting the example or being the fall guy to make a group of people or make a community understand that you can't keep doing things this way or that way. And but yeah, like I said, I hope your shit fails. Um, like I said, make time, take time to do it right, or make time to do it over. But this has gone on long enough. Thanks for listening. Just if you want to hear about other topics that you want me to voice my opinion on, just drop me a message on Facebook, and I'll try to talk about it on my next cast. Again, I'm Ice Cube 57 on the Hemisphere Forum, um, otherwise known as Christopher Parham, and y'all have a good day.